What's brewing, everyone? This episode is all about the materials as well as ingredients needed for brewing compost tea. Stay tuned to hear all that you need to get started brewing your own compost tea. Hey Earth lovers, welcome to the third episode of What's Brewing, a compost podcast, the first ever podcast series all about compost tea. We're making history here. I'm your host, Troy Hinkey. I've been working with and teaching about the soil food web, compost, and compost tea for close to a decade now, starting at the Rodale Institute. I started Living Roots Compost Tea in 2017, where I provide nationwide consulting to growers and composters, local compost tea sprays, as well as a number of other things. Last episode was focused on making high biology compost. High quality compost tea depends upon the biology or microorganisms within it, and that biology comes from healthy compost. Now that we've learned about the soil food web and built that knowledge, along with learning about how to make quality compost, we can start getting into compost tea, and this episode is going to be all about the materials needed for brewing. So let's jump right in. The materials that will be needed are a clean container, clean water, finished compost or vermicast, a brew bag, an air pump or air blower and air hose, and then finally foods for microorganisms. So a clean container, this is our main thing that we need to put compost tea in and brew it. The whole next episode is going to be entirely focused on brewers from small to large, do-it-yourself ones to pre-made ones. So we'll get into all the details next episode on that, but it can be something as simple as a 1 to 5 gallon bucket up to a 1,000 gallon conical brewer that are commercial brewers that people buy for several $1,000s. But we'll get into the details of that next episode. For right now, we're going to stick to this list. So a clean container is going to be used as a brewer. And then we need clean water. So rainwater is going to be best for anyone who collects rainwater. Some people ask about pond water. Pond water tends to be stagnant and have anaerobic microorganisms in it. So I generally recommend not using pond water. And then creek water, you never really know what's upstream from you. There could be chemicals running down or animals that are, like cattle and things like that are defecating into the water. And you just never know what's going to be upstream. Even if you get it tested a month later, it could be different. So rainwater's best. And then the most common one that people are going to use are well water or municipal water. And with municipal water, you really have to remember that there's chlorine and chloramine in the water that's going to be used to kill bacteria in the pipes before the water gets to your house. So we need to treat this chlorine and chloramine in the water, and you can off-gas chlorine or chloramine in the water by letting water sit out. So you'd fill your brewer up and let it sit out for 24 to 48 hours. If you've got an air pump and we want to put an air pump on it, you can run that and do it in a little bit less time, somewhere maybe 12 hours or a little less. And then another way of taking up the chlorine and chloramine in the water is to add humic acid. And we use humic acid I usually use it for microbial foods anyway. So I've got that taken care of to take up chlorine. But if you wanted to use humic acid just to take up the chlorine, you just need to add enough to tint the water. So in a 5 gallon bucket, it really just takes a few drops to add to that to take up and bind to any of the chlorine ions that are in the water there. And then lastly, with water, we need to remember when brewing that we want to brew at ambient temperatures. So some of the details with this I'm going to be bringing up again in the episode all about compost tea brewing, but I wanted to mention this so that it gets in everyone's head that we are brewing at ambient temperature. So there's different sets of microorganisms that are active at various temperatures, and certain bacteria and protozoa are going to be active at 50 and 60 degrees versus other types that are going to be active at 80 and 90 degrees. So if you're growing in a greenhouse and you want to make compost tea for your greenhouse, you'd want to be brewing in the greenhouse. If you're making compost tea and brewing it for plants that are outdoors, you'd want to be brewing in that same ambient temperature that you're going to be applying it outdoors there. So by brewing at ambient temperature, we're focused on having the certain sets of microorganisms active that are going to be active on the plants already. and on the soil surface there. So that's why we want to have ambient temperature with the water. And then after water, we obviously need finished compost or vermicast. Vermicast is another name for worm compost. I like to use a mix of compost and worm compost. And even if I have compost of various ages, I'll use some new compost, some aged compost, and then some worm compost. It's all about getting diversity of microorganisms into that brew. So I'm really trying to get as many different types and sets of organisms that I can going in a brew. So we want finished compost or vermicast. We discussed that in the very first episode, that we're focused on using finished compost or vermicast. And we want something that's going to resemble humus or soil for the most part, nothing with a lot of wood chunks. If there's not much decomposition that's happened within that material, then you're most likely not going to have a lot of microbial action that's going on the surface of that. So we want to make sure, and if you haven't used a microscope to check out the material that you're using, you just want to make sure that it looks like nicely broken down and, like I said, resembles humus. Moving on from there, we want a brew bag to put our compost into. I've had different people ask me on like Instagram and stuff about just not even using a brew bag and dumping materials in there. That's fine for smaller brews, when you're doing 1 to 5 gallons and you're not really messing with a lot of sprayers and little intricate things. But with the logistics of it in larger brewers and having to transfer tanks and things like that, it just gets to be a mess. So it's really good to use a brew bag, and a brew bag can be something as simple as a paint strainer bag. So with a 5-gallon bucket, you can go to a local paint store, and they generally cost $2 to $4. It's a paint strainer bag that has a elastic top, and it's made exactly for a 5-gallon bucket that people put paint in normally. And you just fit that around the top of your bucket and put your compost in there and get to brewing. You can also use those if you're just wanting something inexpensive to get going and kind of try brewing. You can use those same bags and tie up the top to make larger brews, 25, 50 gallons. But I usually recommend, if you're going to be brewing for longer or doing larger brews, the paint strainer bags are really not going to last long. You're going to want to get a high quality kind of commercial type bag. And you can order different of these. They're mesh bags with zipper or snap closures. Generally, they come in small, medium, and large sizes. You can order them from a few different places online that I know of. I have my favorite, but I don't need to recommend it on here. If anybody wants to reach out and ask me, you can. One thing I like about the mesh bags, they're made of kind of a nylon plastic, and if you get a hole in one of the corners, you can repair it easily with a needle and fishing line. I've done that many times. And then along with the brew bag, after that, we've got our clean container, we've got our clean water, we've got compost, and we've got a brew bag. So the compost goes in the brew bag goes in the water goes in the container, and then we need to add air. We're trying to keep this all aerobic, and we want to brew at above 6% dissolved oxygen. So if anyone doesn't have a DO meter, you want the water to resemble a rolling boil, and just to make sure that the water is moving over heavily. I've maybe a long time ago used a dissolved oxygen meter, but I normally just rely on my eye. And then for air pump or air blower, so air pumps are for smaller brews, anywhere from 1 to 100 gallons generally. And air pumps are going to normally cost $100 or less. For a 5-gallon brewer, you're going to spend $20, maybe $40 on an air pump. For something that's going to brew 50 gallons, you're going to be spending somewhere around $60 to $70. And then for when you're brewing, you get up in size and you're brewing 100 gallons, a few hundred gallons, 1,000 gallons, you're going to need to have an air blower at that point. And they normally cost starting range of $700 plus for these air blowers. So after air blowers, then we're going to need food for microorganisms. The whole idea behind compost tea is that we're extracting these microorganisms from the surface of the compost, and then we're adding these foods for the microorganisms to get them to eat and reproduce to very high populations. So foods for microorganisms. The main foods that we're adding this for is bacteria and fungi. Bacteria, there's generally enough bacteria in a brew and in the soil that I'm not really wanting to get a lot of bacteria going. But if you're working with a crop that maybe you need some more bacteria in your brew or whatever, the best food and really the only food is unsulfured blackstrap molasses. And it takes a very minimal amount. I'll mention in a few minutes here, and we'll get into that into more detail in the brewing episode, but really not much. And then foods for fungi. We've got a few different types of foods for fungi. So humic acid. And as I said, humic acid is what we use to treat the water for chlorine as well. And humic acid also does a number of things in the soil, including boosting availability of nutrients to plants. I always use humic acid in my brews. There might be other things that I'll mix up for foods, but I always use humic acid. And then my next go-to food for fungi is fish hydrolysate. And there's a difference between fish hydrolysate and fish emulsion, and most people are not paying attention to this on the labels. But fish hydrolysate is usually more expensive. It still has the fats and oils remaining in the fish, and it's pretty much like taking a fish and putting it in a blender and just blending it up and having all that liquid, that thick liquid with the fats and oils and proteins and things like that. They're going to feed more of the fungi. And then emulsion, fish emulsion is when you've had those fats and oils removed, and that makes the product cheaper, and people will a lot of times be buying fish emulsion just because it costs less than the fish hydrolysate. But pay attention and get the fish hydrolysate. Moving along from fish hydrolysate, we've got kelp next. So kelp is a large leaf in the ocean that sits there, and you can think of all the minerals and decaying fish and aquatic life that this leaf has just soaked up over its life. So it's full of minerals and micronutrients from being in the water and soaking all that up. So it's really good for plants and microorganisms, and it's going to be another food for fungi. So we've got humic acid, we've got fish hydrolysate, and we've got kelp. Then another one for fungi is going to be feather meal. So with feather meal, the way that it acts in the water, it is rather hydrophobic and it doesn't want to really stir into the water. So it's best to add that when you are first adding your water into the bucket. And you may not understand what I'm talking about just over the podcast here, but if you ever use it, you will see what I mean. After feather meal, we've got steel cut oats that are also a fungal food. And I found in the past that I tend to get more ciliates easily when I use steel cut oats. So I've shied away from steel cut oats, but generally I'm using humic acid, fish hydrolysate, and then in the springtime I'll normally add feather meal, and then in the summer and later months I'll switch from feather meal to kelp. So that feather meal is in organics. It's the highest nitrogen source that you can find in organic agriculture. So that feather meal is going to be a good source of nitrogen for plants in the springtime when they need that vegetative growth. And then the kelp will help provide more phosphorus and potassium and other things that they will need in later stages of their plant life there. And I'm usually trying to get at least like 3 different types of foods in there. You don't necessarily want to go nuts and have a lot of food, but it's good to have a few different types of foods so that you're feeding it's all about diversity. I keep mentioning diversity. We want to feed a diversity of microorganisms. You know, if you have one food in there, you're going to be feeding mainly a certain set of species of, bacteria or something like that. And we want to get more than just a few types going. We want to get as much diversity as we can. And then I've mentioned before, and I'll mention again, that we need very minimal foods when it comes to these bacterial and fungal foods. So I always like to use the example of 5 gallons. In a 5-gallon brew, I'll use 1 tablespoon of humic acid, 1 tablespoon of fish hydrolysate, 1 tablespoon of kelp. And then if I'm using molasses, I'll use at the most 1 teaspoon of molasses. And that stuff can get pretty sticky in your brew too. And you also want to leave foods to a minimum because you'll have this sticky residue on your brew tank and then your spray tank if you really are using too much. Lastly, you may want a protozoan infusion. When I've read about a protozoan infusion in the past, I've read about using like green material, grass and things like that, but I've had the most luck with straw. When I'm talking about a protozoan infusion, in the episode on the soil food web, we learned that if we have bacteria and fungi in the soil, that's good because we are breaking down that organic matter, that bacteria and fungi are breaking down that organic matter in the soil and then holding those nutrients in their bodies. But we need their predators to come along, and one of the main predators of bacteria is going to be protozoa. So if you want to get more protozoa going in your brew, or you can even do it separately, I normally like to add a bit in my brew just to help get some more. It's generally flagellates that you're going to see more of with using the protozoan infusion, but you can use a handful of straw in a 5-gallon bucket, a handful, and I'm talking about like a really small handful, and in 50 gallons, maybe just kind of a healthy handful. It really doesn't take much. And I add that the last 12 hours of brewing. And again, I'll mention this again in the episode all about brewing, but I add that in the last 12 hours because I've noticed that if it goes any longer than that, you get too much. The idea behind this is that you're adding a good amount of bacteria, kind of getting a bacterial boom, but also adding the protozoa from this straw, that you get the bacteria going and then the protozoa going because they're eating away at that. But at a certain point, that starts to go anaerobic and you're going to start to notice ciliates. So I just stick with the last 12 hours on a brew for adding straw for adding more protozoa. And then lastly, I want to mention in this episode, because it's extremely important, about cleaning the brewer and keeping brew equipment clean. It's easy to neglect this, and it's one thing that really needs to be stayed on top of because you can form a layer of biofilm on different surfaces. And if you've got somewhere that's hiding, that's got this biofilm on there that you haven't scrubbed away, that it kind of remains wet, you can get some nasty anaerobic microorganisms that are breeding on there. And when you're trying to brew, you're always getting these anaerobic microorganisms that are added in. And it may not have an effect, but just depending on how much there is, it could have a negative effect on your brew. So we really want to make sure that we're keeping all this stuff clean. So right after brewing, it's easiest to do right after brewing. You empty your brewer out, you get it into your spray tank, take the time to rinse that brewer out with water. Then you can use a little scrub pad to get some of the stickiness from fish hydrolysate or whatever might be stuck to the side there. Usually, if you're doing it immediately after brewing, it just takes just water. If you leave it sit around and it's been a few hours or days since you've cleaned it, you will want to use some environmentally friendly dish soap. If that doesn't happen to be enough and you need to use something a little bit more, then I use hydrogen peroxide and I'll add it to a spray bottle and just spray it all around and let it kind of soak in and then scrub it real well. And then with the brew bag too, that brew bag's been sitting in water that's got humic acid and fish hydrolysate and possibly some molasses, and it's going to have the sticky residue on the surfaces of that, and it may not always come clean when you're trying to clean it right away. So a lot of times I'll just stick it in a bucket and leave it sit. I'll get my brewer clean. I'll stick the brew bag in a soak it in a bucket and let that soak until I get back in the afternoon or later part of the day. And then I can scrub it real well with some soap if needed. And use a scrub brush to get all the corners and turn it inside out and get all that stuff and residue out of there and little bits of compost and everything. Okay, well, this is going to be a little bit of a shorter episode today than the past episodes have been. To give you an overview of what we talked about today, the materials that we need for brewing compost tea are going to be a clean container or brewer. And again, we'll get into all next episodes going to be all about brewers. And then after a clean container, we need clean water. After that, we need finished compost and or vermicast. And then we need a brew bag, air pump or air blower with an air hose, and then foods for microorganisms. This brings us to the end of our episode, all about materials and ingredients needed for brewing compost tea. I hope you've gotten a lot out of this episode of What's Brewing, a compost podcast. Next episode, I will be discussing brewers, large and small, inexpensive to costly, do-it-yourself to pre-made, including how you can set up your own 5-gallon brewer and 50-gallon brewer at home rather inexpensively. If you have been learning from and enjoying this podcast, please be sure to subscribe, share it with your friends, and rate it. In the meantime, you can learn more by finding me at Living Roots Compost Tea on Instagram and Facebook, as well as livingrootscomposttea.com. Until next time, this is Troy Hinkie of Living Roots, and don't forget to keep it biological.